This is a demonstration of laminar flow. You may be wondering, what is laminar flow? Well, let us have a look at this diagram. As you can see here, there are two types of flow, laminar and turbulent. Turbulent, which is the bottom half of the diagram, shows random distribution of molecules or particles, similar to diffusion. If you were to drop ink into water, you would see it disperse randomly. Laminar flow is where they stayed in parallel rows and columns to each other, and the movement was ordered. But why do we need laminar flow, you might be wondering? Well, as you can see here, this burly fireman chap, they were having trouble, our colonial cousins were in the Americas, at fighting fires in very tall skyscrapers. And so, one fireman in particular found that if you could reduce the friction in the water would reach higher from the nozzle of the hose. There are two methods of achieving this. One was using a chemical called polyethylene oxide, also known as polyox, a self-siphoning goo. And the other, which I imagine was a cheaper alternative, was to use laminar flow and to fit various filters onto the hose to order the structure of the molecules so they would all flow in the same direction. When they did that, you found that the water became clearer and would appear similar to liquid glass. And so here is our demonstration of laminar flow. We're using fairly crude equipment, so the demonstration might not be as spectacular as you might find at other sources, but still a good demonstration. We have a small beaker here holding a even smaller sample jar. And in the space in between the two, we have filled with a very clear viscous liquid called corn syrup, which is widely available in the Americas, but not so much over here, although it is widely used by the food industry. What we are now doing is colouring the corn syrup with some food colouring and adding that into the corn syrup in between the two glass vessels. As you can see, the corn syrup coloured does not tend to diffuse like ink through water. This is a testament to its viscosity. As you can see, we are just adding the third sample now. And we will begin to mix the colours by turning the inner vessel and causing them to mix. What we imagine is happening is that they are not mixing as such, more that the layers are sliding over one another. Similar to if you had several colour filters and looked through a red one, and then if you were to take a blue one and slide it over the red one, the colour would become darker, as you can see the sample is doing now. As you can see, we have mixed the samples by turning the inner jar the one way. We are now going to reverse its flow by turning the jar the other way, and as you can see, we are slowly reverting back to somewhat its original state. Due to the bubbles and the crudeness of this equipment, you can see that the samples will not look as their original exactly, but it is good enough to show the effect is true. And there you have it. A glorious demonstration of laminar flow. On a side note, our boy who devised this experiment would like to point out that while the bubbles are a hideous mistake on his part, which he feels terrible for, they do prove that we haven't simply wound the video back. This was a glorious scientific demonstration. Thank you for watching.